Yes, last week we dealt with characteristics of data. We have dealt with means, the arithmetic mean, and the median. And then we also dealt with another metric, variance or standard deviation. And this week we also want to deal with metrics, but this time we have a different situation. Namely, we have two different data sets, and we want to understand whether these data show a relationship. And for that, we want to introduce something called important correlation. Yes, let's get started right away. We are dealing with what is called linear correlation. It will become very clear again during the week why this is important. So we have the following situation. You are measuring two characteristics, so you have two samples from univariate data, and you are wondering whether there is a relationship between these data. And our task now is to provide an answer. To that, in the context of metrics, that we can determine. And the answer is, in this case, a correlation that can either be negative, non-existent, or positive. And this is something that is often said in everyday language. You have heard it before. Something is positively correlated, negatively correlated, correlated. Especially in the social sciences, such analyses are often conducted. And yes, we want to clarify this a bit mathematically. To do this, we will look at a few examples of what we expect a positive correlation to be. And the following is actually an example of a positive correlation. And what do we see here? We see the relationship between two characteristics, namely height, in centimeters, which would be on the x-axis from 1.65 to 1.85 in me. And on the y-axis, you can see the weight of the person with the specific height. And these two characteristics are positively correlated. And I ask you again, perhaps you can take a moment to consider what that might mean. Well, I will give you the answer directly. A positive correlation means that when one characteristic increases, the other characteristic will also increase. Conversely, when one characteristic decreases, the second characteristic also decreases. And this is indeed the case with height and weight. So, the taller a person is, the more weight they tend to have on average. Similarly, the smaller the person, the less weight. And of course, you can also see that if we try to represent a trend here, we would draw a line to illustrate this trend, which has a positive slope. All right, let's take a step further. Now, let's look at an example where there is likely no correlation. And this is when we look at a person's height and, for example, their monthly income. Yes, we assume that there is no relationship between these two variables. And we can see here a bit that we are not seeing a trend going in this direction or in that direction. This means that presumably one would need to draw a trend like this. And that means if we suspect a correlation of 0 here, it would mean how to calculate this will be explained shortly. And now, let's look at the last example. This is an example of a negative correlation. Here, I brought an example examining the outside temperature and the heating costs. So here, let's take another look and briefly consider the relationship between the two variables. When the temperature rises, we need to heat less and the heating costs decrease. When the temperature is low, the heating costs are high. This means that on average there is a negative correlation. When one increases, the other decreases. And when one decreases, the other increases. And we can see this here as well. If we were to draw the trend, it would also be a line with a negative slope. Yes, these are examples of correlations, just as we often use this word in everyday life. In the next video, we will look at how we can define this mathematically and also calculate correlations. Until then,